This video is going to talk more about the area and perimeter of rectangles. Be sure the date and topic are at the top of the page. We're going to go ahead and call this part 2. The essential question for the video is, can the area of a rectangle change without changing the perimeter? This essential question probably sounds very similar to the one we did yesterday, and if so, that's a great observation. Yesterday we thought about the area staying the same as we were building our garden, and we looked at the different perimeters that we could find. This time we are going to keep the perimeter the same. You can see here that we are not changing the perimeter, but we are going to see the area, the effect it has on area. Once again, I'm just going to briefly remind us of our two main terms. We'll be using perimeter in this video, so remember please that the perimeter is the distance around a shape. And of course, area, which is the space inside a shape. So again, we're going to play around with this information to see a bit more of some properties of rectangles. But this time, we want the area. We want to see if the area will change, but we want to keep the perimeter the same. So let's suppose this time that we want to make a space in the field behind our school to reserve for tag games at recess, and Mr. O'Neill wants to rope it off. In his office, he has 24 meters of rope. With this rope, we want to come up with ways that Mr. O'Neill might structure the space, right? Is there more than one way he could lay out the rope to make the space for tag? Well, of course, right? There are lots of different ways that he might put the rope out in order to make that space. What we know, however, is that we have 24 meters of rope. We don't have 24 square meters. We know we have 24 meters. That means that the perimeter that we're working with is the outside space. It's going to be the rope that goes around the play area is 24 meters. Our job is to come up with the ways that we could hang the rope or block off the space using our 24 meters of rope. We just, of course, as last time, want to make our space a rectangle, and we want the sides that we choose when we're putting the rope out to be whole numbers. So since the perimeter is going to be 24 meters, it means that all of our 4 sides must add up exactly to 24 meters, since that's what perimeter means. So let's think on a few suggestions. One thing I could suggest for Mr. O'Neill is that he makes the space 11 meters long and 1 meter wide, right? That would work because if I added up the sides all together, I'd have 1 plus 11 plus 1 plus 11, and that would make 24 meters, which is what we're looking for, right? So that would be one way we might be able to section off the area. But I think, just like last time, there are other ways. So I'm going to create a table to keep track of all of our options. So I have a table here with 4 columns: the length, the width, the perimeter, and the area. And I'm going to keep track of all of our options. So the first one that I just gave us on the previous slide was that maybe the length would be 11 meters, the width would be 1 meter, and together that would make the 24 meters that are required. Right? I could also make the space 100 meters wide. The length would be 2 meters, and again, if I add 10 plus 10, that's 12. And I have that twice to account for the other 2 sides of my rectangle, that would also make 24 meters. So just like before, I want to take some time to let you guys come up with all the different ways that you can think of to have rectangles where all 4 sides add up to 24 meters, and you're going to record them on your table. We'll come back together in a few moments while I generate my list and you generate your list. So we'll come back and share what we have. Whew, that was a long list. How'd we do? Do we have all of the options that we could make our rope 24 meters and still create a rectangular shape for the play area? Be sure to add any that you didn't already have on the table if you missed some of the ones that I have here. So now that we know the different ways we could design the space, we actually want to know now how much room there is inside for people to play their games, right? We want to hopefully design it in a way that has the most space available so that we can play lots of fun games inside. If we're trying to find the inside space for people to run around, we need to now know the area, right? The space inside. So again, this is where the video is going to do something a little different. I'm going to leave this area column blank. And tomorrow, you guys will come to class with it filled in and we'll be able to share what we found. I'll go ahead and do the first one as an example. So I'll make a quick sketch and show how I'm going to calculate it, and then you'll be able to do the same to finish this off. So our first option that we talked about was having an 11 by 1 meter rectangle, right? And that gave us the perimeter to use the correct amount of rope. But to find the area, I have to remember that the area is found by doing the length times the width, right? So in this case, it would be 11 times the 1. So my area for this first option is 11 meters squared, right? It's not a very large space. 11 meters, square meters, would not be a particularly large place for us to play, right? If we looked at the next one, we could say, oh, the length times the width would be 20 meters squared. So already I can tell that a different shape might have more space for running around. I'd like you to go ahead and finish the table on your own. I'm going to leave the rest of this blank, but tomorrow in class I will check that your table is complete. Remember, the essential question of the video, and what we'll be discussing more tomorrow, is can the area of a rectangle change or vary without changing the perimeter? So we'll share our thoughts on that tomorrow. Be on the lookout for any observations you can make as you're completing this table and what you might notice about rectangles that give you more or less space inside.